In this lesson, we'll be looking at a system of nonlinear equations. And if you think about a system of equations that we talked about before, we were looking at two linear equations where we solve with graphing, elimination, or substitution. And today we're basically looking at the same thing, but instead of looking at linear equations, we're looking at nonlinear equations. But that doesn't mean they're both nonlinear. So a system of nonlinear equations is basically a system, which means we have two or more equations, in which at least one equation is nonlinear. And remember from before, the solution or solutions, depending on how many there are in the problem, is the intersection of the functions. So it could be one, it could be multiple, or the equations. Okay, so the basic idea is still the same. We're looking at what are the two functions, right? What are the two equations? Where do they meet? So we're going to just do graphing in this video, and we'll look at the algebra in class together. So I think this is the best way to visualize your solutions. And remember, you could have one, you could have two, you can have three, you can have no solutions. It all depends on how often they intersect. So what you want to do is you want to make sure you graph both functions. So if you look at this, we have two different equations, and I'm going to call them A and B, and label them on my graph. And then we'll graph just like what we've done before. So remember, graphing the quadratic equation for A, y equals x squared minus 6x plus 5. I'm going to start by finding my AOS, right? X equals negative b over 2a. So that's 3, and then I can make my table. And to save you some time, I went ahead and already calculated these points, so we can just go ahead and graph this. So the points are 1 and 0, 2 and negative 3, 3 and negative 4, 4, negative 3, 5, 0. So I'm going to go ahead and graph this on my coordinate plane. And of course, draw the axes first. I'm going to move my origin just over a little bit, since it looks like I'm dealing with mostly positives in my table. Alright, so here's my x, here's my y, and I'm going to go by ones. Okay? And let's go ahead and graph this. So 1, 0. Oops. Oh, my hand keeps moving. There we go. 1, 0. 2, negative 3. 3, negative 4. 4, negative 3. 5, 0. Right? So here's my graph of A so far. So I'm just going to label it, color code it, whatever you like to help you distinguish the two. Okay, then B, you'll notice, is a linear function, y equals x minus 1. Do you remember how we graphed that? Well, that's the y equals mx plus b. So m is in front of x, which is 1, which is the same thing as 1 over 1, which tells me the rise, I'm going to go up 1, and my run, right 1. Right? Positive is up, positive on the bottom means go to the right. The y-intercept is 0, comma b, so that's 0, negative 1. So I can simply go to my graph then and start at 0, negative 1 and count up 1, over 1, up 1, over 1, right? To create this line. And you might be able to look at this and say, hey, look, we've got one solution right here, right? Because that's where the blue and the red, and I forgot to label my graph, so I'm going to call this graph B, where the blue and the red intersect. So this is graph B. So we have one solution here at 1, comma 0, right? Because that's where they meet. But then if you're looking at this, you might say, wait, it looks like it's going to hit again because that red parabola is going to keep coming up. And when I look at this, I think it looks like it might hit at 6, 5. But I'm not 100% sure. So what I might want to do is just double check that really quick. I'm going to plug in 6, right, and see what I get. And when I do plug that in, it actually works out to be 6, 5. 1, 2, 3. Wait. Yes, 6, 5. Right there. All right. And there is that second intersection. So we also have a solution at 6, 5. All right. So again, if it looks like it's going to hit, double check by plugging it in, right? Always plug in to check. How do you know if they're the solutions? Well, remember what you can also do to check the solutions, plug them back into each equation to check. So plug in 1 for x, 0 for y for both, plug in 6 for x, 5 for y for both, and they should both work out. Okay, and that is just really it, a refresher on graphing and looking for your solutions. Remember, you can also get no solution if they don't intersect, and you can also get 1. So let's take a look at you try 1 and you try 2. And I'd like you guys to try those. Being careful with number 2, you're going to get a fraction as your AOS for negative 2x squared minus x plus 3. So think about what numbers you're going to pick, and remember, if you can't figure out the perfect number so you can, reflect those points, just plug in all 5 and it'll be fine. All right, so we'll come back and check your answers. All right, so check number 1. We should have one real solution at negative 1, negative 7. Again, make sure you do me a favor and label your lines on your grid so I know which one goes with which. You can definitely feel free to color code it. Let me know if you have questions on that. So that one only hits at 1 point. And number 2 should be no real solution. And this is what I was saying earlier. When you get your AOS here, which is negative 1/4, and you're racking your brain here, if you're trying to figure out numbers that are on the same, the same distance away from negative 1/4, you're going to end up with fractions. So I just went with the closest numbers to it and just plugged it in 5 times. It was no big deal because there were numbers like 1, 0, negative 1, and negative 2. So you'll see how my points aren't, reflected over, which is fine because I still get a parabola. Okay? So no real solutions there. We'll look at the algebra in class. Please come back with questions. Thanks for listening.